recording. So during the last lecture we have added scripting capabilities to our data panel application. So we can create a JavaScript and run it, and it will be able to interact with the plugins. It's still a bit incomplete, so for example it does not auto-reload plugins, which needs to be added. But if we just try to reconstruct what we had, so we add a plugin with the name we expect, the plugins will be directly exposed in the script with their names, and then if we press run, we're able to call a function on a plugin with a list of arguments. The way this is implemented is very generic, so we do not create special C++ wrapper functions for every plugin function. Instead, we just have the generic call function, which takes a function name and a list of arguments. The advantage of this approach is that it allows us to easily add various functions to the plugins, and the hosting application doesn't need to be aware of every plugin function that there might be. The downside is, of course, that the script is a bit less elegant than it would be otherwise. There are different approaches how this could be improved. For example, dynamically populating objects with functions. But for now, we will stick with this call behavior. And first, we will improve this application a little bit. So we'll add today a function to automatically load the plugins and their configurations as they were loaded the last time. We might change this from a automatic reload like with the script on start to something that you really load the configuration or save a configuration to a file that would be more flexible. And we'll do a few improvements on how we have implemented the existing mechanism. So first improvement will be that here, when we want to call a function of the script from the C++ side, instead of using eval, we will do it in a bit more sophisticated way. So we will QJS value func. We will just get the object, the global object, then resolve the particular function we want to have on test. So this gives us a object. It is not yet said that this is a function, so we need to check if is callable. So if this is a function, then we can call it. It's like function call. Yeah. As you see here, we could also pass some arguments to the function in the form of an array, but we don't have to do it now. Although we could also change it slightly here, that if that we make a negation, and then we return a different error message if this is not a callable function. So we can just stick with script error for now, but later we might want to add a defined error code. Script script on error %1 not okay, let's see if this still works. So we have our script. We comment this line out since we don't have the plugin loaded. We then just press run, and it runs, so it executes the log line. And this is a more elegant approach than using eval each and every time. Actually, this can be done with even more elegant like this. Okay, another thing that one might want to improve is the mechanism how we get access to our own script engine from within globally defined functions. So unfortunately, the QJS engine does not give one a very convenient way of adding global functions. There are like workaround ways. So one could just add an object, a global object, and then move the functions from the object to the global. So the global object basically is like the namespace you have when you don't specify anything, and you can create objects inside the global object like we did with the plugin. You can have functions in the global object, and while it's easy to add objects to the global object, it's not so easy to add functions. We did this here. Where was it? Here. With a bit of a low-level approach, so we imported some private headers, and then we created this logline function, which then is implemented here. And the way it resolves our own object here is through a lookup map and saving some handles, so it's not very user-friendly. It works, but there is a bit more convenient way how this can be achieved. So as I started explaining earlier, one would be to just add an object like all these plugins here with the set property and object, and then map the object's function onto the global object itself. And another one would be to make our approach here just a bit more elegant. So let's do this first. So first of all, we need yet another private private include. Zack. And then here, so first of all, we can comment out the old mechanism so that we don't have redundant code. Do we have, yeah, this also is old. Engine map, we don't need the mutex. Okay. So instead of using such a lookup and associating the handle to the engine with our own object, we will just instantiate our own object in the global namespace as a special variable. So engine global object set property. Let's call it this thing, set property. Let's call it underscore native context, comma engine new object this. That should not complain. Why is this complaining? New queue object. This. So now, like we have here the plugin object, we also have an object called native context, just with a small o. And then what we'll do here, instead of using this resolution function we had before, instead we will just use resolve the object. So we will peel out the native context object from the global object, and then we will from this be able to get a pointer back on our script engine, and on the QGIS engine, for which our object is the parent. So then we just resolve the parent, and then voila, we have what we wanted to have. But this process is again a bit complex. So qv4, we access again some private functionality of the engine. The downside of using the private objects is that Qt might change at their own discretion the API at any time, so we don't have any guarantees that things will stay the same. So if you update the Qt version, the code might just not longer compile. qv4 new identifier literal. Actually, let's just copy the whole thing from here, so that even if we have a typo, it won't matter. That's all. So we have the missing. So we have our name, then scoped value, context value, scope, file here, global object, global object, get name, scope, global object get name, q object per object, if q file here, scoped q file here, oops, object wrapper, q object wrapper, wrapper scope, the context value, semicolon, and if this thing is something, then q object is equals wrapper object, why is this complaining? It was per object, sorry. Point object q object. So now at this point we have a q object, and it probably will be the QJS engine, but we don't know yet for sure that it actually really is that. So we need to use a q object cast to convert this. So engine is equals q object cast script engine asterisk per object. And the way this casting operation works is that if it's a q object but of a wrong type, then it will just return null instead of doing the cast. So we should here for safety check that we actually got something out of this operation. Okay, that's it. Let's run it, and I see there is something here that we can also comment out. So this is quite a bit more elegant because it's really a self-confined solution. We don't need any global objects, and generally in modern code using global objects is not great. So as you see, it works. We are able to print the log to our log here. So if we put a breakpoint there and run it again, we see that it works fine. So these are the few improvements to the existing code base. Now we will proceed by improving the functionality. So I probably should have closed it. So let's first take a look where we would like to add something to load and save configurations. So probably here next to start stop we make a battery separate, and then another two buttons like load profile and save profile. Of course, in a more production build, we would not just use labeled buttons, but take the time to find some nice icons. But this is, in our particular case, really just a bit a waste of time, so we will just stick to the labeled buttons instead of looking for nice icons. But there are more than enough websites online which have more than enough free icons, at least free for open source or non-commercial projects. So often it's easy to get a free account with them, and then you can get all the icons they have they offer. So let's go here. Let's start stop button. Then we want the vertical separator. So separator. Store on load on store. Then of of course need to define those functions here somewhere. On load, on store. Actually, we should copy those names. We'll need them in a second. Then we go down. Okay, let's see what we are missing. We can just grab this. We already have like load and store functions for the script itself, but we'll also do more or less the same thing just for the whole data set that we have at our disposal. So actually, let's just really copy everything, and then we'll just adapt it to our need. No, that we don't copy everything. We do it differently because here we are really using like the QFile object to save and load things. But since we have more data and we don't want to invest time into inventing some own file format, we will just use the ini format with the Q setting that we used before to save the script between sessions. So load that's many typos. Configuration, store configuration, and we use this here. Q setting as the conf. Let's see. So this we will comment out. Actually, we actually want to load the data. Let's just leave it in place. Just copy those two lines and the config here as well. Okay, so let's first do the store. So let's just first drop the lines that we have saved so that we don't lose them. This one will be for here. And of course this will not be longer called the conf. Let's call it just pconf. And instead of the application directory, we just take the path that we have selected here. We should specify a filter. I don't recall the syntax, so let's quickly look that up. Yeah, that's the syntax. Just we will adapt it to not. First of all, we don't want translation. Let's keep translation. Script files, no, config files. Config. Just asterisk ini. This will use here as well. I mean, we could also call them conf. The file extension does not define the file content. It's just a hint, a polite hint. One is always free to ignore it. Right. So we have our conf here. Actually, we could even improve this. Just call it conf and use make it here local on the stack. We don't need to use pointers here, so we can just set value. Well, script text that is as good as it goes. So here the approach will be quite identical, just that here we get the value, and then we will of course add to do run plugins, save plugins. We just check whether this works, so that we save one config file, then we can comment out the other files. Downside of this approach is that it encodes all of the ini data of the script data. What do we have the file here? Into one single line, and we might at some point with much longer scripts run in some limitation that it would maybe say that it cannot process arbitrarily long lines. The typical Windows functions for processing ini files have limits. I would guess Qt just implemented everything on their own, so probably it will not have a limit. But this is just something to keep in mind, that one maybe want to have like a double file format, so that you save as a conf and it with the same name, but .script or .something saves the script in a second file, so that you always need to handle two files One could of course go and approach and write an own parser that you then just define that the whole section of the ini just doesn't contain ini formatted data, i.e. key value pair separated by a equal sign, but that really would contain just plain text, but the Qt's QSetting class is not capable of this, so you would then need to implement the whole functionality manually or fork the existing Qt class. Although the way those Qt things are designed, they're using a lot of private defines, like we kind of did in the engine example shortly before. And thus, if you do such things, then you run into the situation then when you update your Qt, your fork might break. So it would be more elegant than to implement such a thing from scratch. But anyhow, we wanted to test it, so as you see, it's of course the old mechanism still loads, so we just now will store something as test.conf. I think it will work here somewhere. Yeah, we can always open this with Notepad 2, and as we see here, it works nicely and saves the thing as expected. So now we will get rid of the automatic saving and loading mechanism, so that we always need to use ours. Load. Well, first we take a look that it's really empty, then we load test.conf. Voila, it's there. At this point, it's kind of questionable whether we actually need the open and save here for the script itself. But let's just leave it there, since you might want to handle the script separately from all the plugins and stuff like that. So for now, it's fine. But as said, now we need to save the plugins. So we'll go here. Let's see. We should have certainly used plugin manager already before to list the plugins, for example. Plugin. Okay, I thought I would find it faster. That's a bit much clicking. That's what I want. Right, so we get the whole plugin list, and then we just iterate through it. So we should think about how we want to implement it. I would suggest doing it such that we'll have like a group called plugins, like with a group called script, but the group called plugins would only contain a list of plugins. And then for every plugin and its particular config, you would have an own group again. The limitation of this approach is that, well, it's not super elegant to enumerate a whole section, but we will just do it. And often, so with the Qt implementation, this is also to be done quite easy. There are other ini implementations where it's quite a bit more difficult to get like all entries. You need to always know the key. So there you just go by numbering them from from 0 up to however many they are, and then just reading them until you find the missing value and assuming there are none. But then of course, if you manually edit the file, that causes complications. But with our approach, that should not be so problematic. The alternative option would be to just create a list of all the plugins and save it as one variable with some defined separator that then can be used to break this again in a list of individual plugin names. So there are various approaches how this can be nicely done, but let's go with the one as already outlined. So we have our plugin. So we need its name. Get name, qstring name. You will need some counter. Plugin counter, so that we can create individual names. Although we could use the name of the plugin and as value store its path. That's even nicer. So let's do it like this. So we have name path. I think plugin doesn't keep its path. It does not, so we will need to add this functionality. So DLL plugin, and then of course it will only apply to DLL plugins. So let's see, the plugins do not return a factory, although that might be actually nice if you would add to the plugin the ability to always give us the factory they were created from. Yeah, let's just do it. Plugin factory. Empath. So this will be a very important function, so we call it here just get factory. If we just return mp factory, and we will mandate that this needs to be specified when a plugin is instantiated. We are not using smart pointers here, so we will work on under the assumption that that the factory must always outlive all its plugins. There it is. Oops. Zack. Empath. We already have a factory is factory. And then we just add this to everything that we derive from our let's see, plugin. Okay, we have a few things. So first of all, let's handle our here we already even have factory. That's nice. We actually even save it. Okay, so in in this case, let's just move this here. But the DLL factory, well, then it's just DLL factory. So this will be just plugin factory and class because it's not yet defined. I hope this thing can handle it. Otherwise, we need to move it into a helper object of sorts. Here we didn't, but where were we here? Factory. Let's see what all broke through this change, because this was a non-insignificant change. So here, if you're of course missing a semicolon, it was to be expected. And here, DLL factory. This we need to pass. This is not a DLL factory. This is just a plugin factory. Right, and this we need to change here as well. Class plugin factory. Yes, we get rid of this. Is complaining. This is not defined. Okay. Plugin factory, that should actually be fine. And parent. Oh, const. Get rid of const here. Let's be consistent. Plugin factory. Okay. Okay, so right, and this function itself is a const function, so this here is a const. This should just go to the factory asterisk, then we get rid of the constness. Okay. So this is okay, and we'll just go to our data panel, comment out the incomplete code, and just run it to see, compile it to see where, if anywhere we did break something. There will be, might be some places, but apparently this this works. This is surprising because plugin. because we have derived things from a plugin which do not feed it the mandatory factory argument, like demo plugin here. We excluded that from build, that's why it's fine. Okay, so we can just ignore them. That would be fine. Here we see that the IntelliSense is already complaining that it's missing, but since it's excluded from build, it doesn't bother us. Okay, so this is done. And let's here proceed with that. So plugin get apps plugin get factory, and then we can call something on the factory, but this will be the generic plugin factory. So it's a plugin factory factory is equals this, and we want the DLL plugin DLL plugin factory DLL factory yeah, why not, is equals, I mean, we could have made it a one-liner, then just get rid of that. No, let's keep it as it was. Q object Q object cast. And if this is, so if this is something, so let's here name, and let's call this no, value get well, that thing also doesn't have a path, but we will add it soon. And oops, IntelliSense is explicitly annoying if you try to call functions which you have not defined first. They always then kind of tries to, when you press tab, takes whatever there was. This get ID, so we'll take this get ID if we don't have a DL factory, because this works for all the different factories, even though the built-in ones. And later we will look into getting this, separating this. And our get ID the plugin for the DLL factory was implemented, I think, such that it just gives us only the file name of the DLL. Yeah, it just takes the file name, but the whole plugin path is now something we also want to keep. So we'll just add ID path path, and this is not a override path, only exists on this thing. And path will be added here as a QString. Plugin path create this path is equals. Oh, we probably could have resolved the path from the library. They wouldn't need to save it explicitly, but let's so because library will have a probably file name. Yeah, it has. So that kind of was now not really necessary, but let's keep it saved explicitly. Why not? Right, data panel get path. Okay, so now conf set value plugins plus name comma value. Okay, and now we need to save also all the individual parameters of the plugin. So we go to our window plugin add window that had the parameter enumeration. So this makes get params. Well, we already get a variant list, but let's maybe actually this is quite convenient. Did we make this static? No, we did not. We have get param and load param. Yeah, let's just copy that and to there. We can later, if we want, put it in an own function. Data panel. So we have our plugin, but this is not plugin, this should be factory. Okay, this we don't need. Factory, param type. Didn't we have something for this already? Call function. We have here myvar. Param. Let's see. Well, we have this here in this get params. Well, we could use this. This is maybe more elegant. Let's use that approach. Plugin get params. Q variant list params. Here we get already a full list, so this is nice. For each const auto reference param. Now we need the names. Wait, and this is a list. Then we will need the other things either way. So we will need to make a combination. We just need the count of the name. Somewhere we had a call for names, but it will be in the other. So we take all the params. We could validate that it's actually the same as the param count, but for now let's don't do that. And when we go to our plugin, we had here name resolution somewhere. Default param name there. Here it is. Okay. Now the names are, I think, a bit human readable, so we might want to add a separate function that would allow us to define just IDs, like get param ID, not get param name, but this let's do it for later. So here we said as name we take name of the plugin plus backslash plus then the name of the parameter, and as value we take just the param here at this index. This will not work if we have like a parameter which in turn is a map or a list, but currently our param interface between the plugins does not support such types, so this for here is okay. And if we add such types, we should just then remember to not make them here part of the parameters. We could use this as arguments in function calls, certainly, but we should not use it here. Or alternatively, we could also use an approach where we check here if it's a list or a map, and if it is, we then use Qt's built-in JSON encoding mechanism to encode as a single line JSON the whole remainder, and then put this as a value, breaking a bit with the ini syntax, but this would be a very workable approach, not necessarily super elegant, but workable. So let's test if this works as it should. It should for now be quite simple. We have a what do we have here? Plugin info. Oh, that's just a warning. Assertion, object macro. Didn't we have made this a key object? This is a key object. And here it should and oops, and this is derived from that. That should also be fine. Let's what does get factor return? first plugin factory. We should say that this is a class. That should not change anything. But it has QObject macro. I mean, the simplest approach here would be to revert the change a bit. But the problem will be that we don't have this plugin factory defined before our plugin, and I guess the QPointer is not happy that this thing is something not too well defined. We could revert the change, make this a overwritable function, an overloaded function. Then for the other factories, we would then just need to implement some other mechanism how they would how those plugins would return a pointer to them. Let's see if we can somehow trick this thing into working. And we could go with I don't think this will make a difference unless we have here somewhere a type which I'm not seeing. Nope. Still complaining here. CTRL plugin factory and this. Oh, it doesn't have a QObject. That's why it was complaining. How did I miss that? Yeah, that makes sense. Zack. Yeah. Right here, so let's load test and then add a plugin called test with 4 channels. Now store test 2. Okay, something didn't go quite as planned. This is null and plugin instance is also not null. Params is null. Params shouldn't be null. Why is this not the right size? Params count 1. 1 is correct. Per params. Size. So params itself. We resize it. But then it should be resized. Well, it has a value. It should have an address, but here just pass 0 as an address. That is not good. Let's put a breakpoint here. If you add some debug code here and see what's happening. So auto test reference test is equals this. No, we want the pointer, so auto pointer. Okay, put a breakpoint here. Okay, in this case we just add the plugin and then just try saving it just to see that we get an error test. Oops. Test 2. Right. Run params. Oh, I see the problem. Too many variables with the same name. Here we should, of course, go through either p params or v params, because the size of just params is at this point null. Params will become something else only once we have completed this call here. That should have never have worked. Script load test add test with 4 channels, store test2. Okay, didn't crash, that's always a good sign. And voila, so we have our script. We have, for each plugin would have such a line containing its path, and then all its parameters stored as an own section inside our ini. So this is nice. So now of course we need to be able to load this. So we go here, for each const reference name, name and conf what was it, keys? I think it was, no, it was, oh my, was it, let's see, all keys, that was like the all sections, I think, or that, and the child groups, it wasn't right. Child keys, does this take this? This doesn't take an argument. Can we only enumerate? I thought settings had the option to enumerate only one section, but it might not have that ability. But we can always go with all keys. So let's first see what all keys actually contains. Test x auto test is equals all keys. It might be that we just need to filter it then by section, but this would be only a minor inconvenience. Oops, the wrong button. Load. Let's see. So all keys gives us yeah, really all keys that they are. This is not super great, but we can work with that. Right, so and this then we call key. If key.begin starts with plugins, or rather if it not starts with plugins, then continue, else string name is equals key punct mid 1 2 3 4 5 6 7 8 mid 8. Let's just quickly see if we have the right offset. Load test2. Yeah, that looks correct. So we have the right offset, and now qstring value is equals conf value key, oops, to string. So this gives us the path. So if contains so if this is a path, as but we don't have any built-in plugins currently. So we could also just go with just continue. So we skip it if we found it, else we can then continue further down. So we need to instantiate the plugin, and before we do this we probably should get rid of all the existing plugins, but let's make this a to-do for now. plugin, so let's grab this. This will be here mostly the right code, so we want to, but we need the factory by name, so mpap login manager get factory get factory by ID, and I guess we just did this only by the file name, not by the full path. Well, then we just need to resolve the file name from our path. Did we define this somewhere? No. And this should be of course here. Value split backslash punct last. What was the return value? Was it a smart pointer? That was a smart pointer. Then let's stick with the smart pointer. Okay, so oops. So if this is not found, then continue, and we should log an error. Log any lines from here already? No. Just call this log line translation error, comma login %1 not available .arg, and here we put the whole path. That was value, and we continue because we cannot do anything else. So we have, now we know we have the factory, although we need to have it persisted. So let's put this here. In principle we could have this even down there, because the factory might not, but might also not exist for a built-in sort of plugin. So factory, the name, name we have. Set params. Now we will need to read the params. Add plugins dirty true. Yeah, but this can only be set once we are done. So here we will want to read all the parameters from our thingy, but we already know what to expect to some extent. So let's see. We do not get params on this thing. Here we just go with I did this called DLL factory. We should go just with factories to keep this generic. Yeah, okay. Right, and here of course it's just factory and DLL factory. Good. Right, so here also just factory. Get param count. Q variant list params. Then we of course want a name. Q variant param is equals conf punct value. This is correct, but we should also provide a default value. But that would complicate things, so for now we don't do it. We just write here get value default from factory, and params append param, and that might be all we need. Let's see. So script store load to zack Well, something went wrong. Plugin not available. Why? Apparently this thing here failed. Let's put a breakpoint here and just repeat it. Load to load. So let's see. ID was demo plugin DLL and factories contains. We probably lowercase it or something like that. Nope. It should have worked. Let's see if it really worked. Factory. Oh, huh. There was a exclamation mark missing. So it should be fine. Load. Test. Okay. Don't need this breakpoint anymore. Close. It loaded it, but for some reason we got 0 channels. This is not quite right. Name, plugin factory param name. It looks correct. Param looks also correct. Let's see what our params contains. Load. Test 2. Params. Well, there's one entry. And the one entry is 4. So this should be correct. And we added the plugin. So for some reason, okay, let's go to the add plugin. We have set param. Okay, set param. Do we have like a function which would well, okay, let's just put a breakpoint here and see where we go from there. Zack. Zack. Okay. Params. 0 is success, so but here pparam says size is 0, which is not correct. Param size was 1. Resize. Okay, let's put a breakpoint here and run it again. Zack. Now it says it's 1, so it probably was just that the return has already cleared some data, so this was not the problem. Let's add the 0. Why does this not work? Let's check the code which should populate our channels. Channel count. Maybe we don't trigger it properly or something like that. Script load. Zack. Channels. Well, channel 0. This is not correct. So something is clearly broken with our set param mechanism in some way, or the value. It might read the value always as text or something like that. So let's go there. And put a breakpoint directly here, and then we'll see what is failing. Load. Okay, let's go inside. Once we are inside, it might be a bit more steps. Okay, so we are here. Count is 1, which is correct. Channel 0, okay, and then we want to convert this to a 64-bit number. Because this thing is a type 5. What's type 5? Probably a string. Type 5 is a string. This is a bit annoying because so our ini file does not really write down whether something is a string or a number, and Qt can just convert between them. But if we then rely on the type that is given, then we'll end up with a wrong conversion. So the proper fix for this issue would be to make our variant capable of auto-converting from string to the other types which can be mistaken for a string. So yeah, I guess we will have to do that. So okay, so let's start at the start. So if this is string, what if this is string and this is string, value, so if equals true, true, and true. Actually, we should make this case insensitive. Can we make this case insensitive? No, not easily. Let's just leave it at the 3 most common notations for true. Then of course if it's 1, or rather if it's a number and it's not 0, so get you int if get you int not 0, then it's true. And else it's false. Okay, so then of course the next two here. So if this is a string, then return this toy 64. Well, do we have a oolong version of that? We don't. Okay. Value punct c string. Yeah, that can be a one-liner like this. Same for here. We only have a function for signs, so this will not cover the whole range, but this should be good enough. And double, how do we do double? Tough, I guess. Zack. Yeah, and string. We already implemented a toString that does the opposite and allows us to convert everything to a string. So okay, that should now load it correctly. Load. We don't need that breakpoint anymore. Or maybe we do. Apparently something was still not quite correct. Load. Maybe I just picked the wrong. No, I didn't pick the wrong test, because then it wouldn't have done anything. And we should put a breakpoint here. That will be faster to arrive at the next time. Let's see. Let's go inside here. Oh, this is that was carelessness. It should, of course, if it is string, then do that. Wait, we have one more bug. For double, the same issue applies. Suck. Load to. Let's assume it works. Yeah, so this works now. Right, and of course if we then start, then it will plot the 4 channels. You might have noticed I have fixed the legend, so there is a new version of the QWT library uploaded to Moodle, which works with the latest Qt version correctly, so that really was a issue with the slightly older library that we have been using before. Okay, so we have this. So the next step will be some ability to start and stop the measurement from the script, so that we don't need to press like start stop there, but instead we can just start stop the script itself. Or we could go with another approach and run the script when we press start. That might be more intuitive. So let's go with that. On start, plugin manager start. Well, the thing does it start, and if there is no error, well, if there is an error, then display error. So we can maybe here log this on the log line. %1.arg. Of course, we would ideally want some function that converts the numeric error code into something explicit. Stopping measurement with less typos. Right, and if everything was successful, yeah, so if we have no errors, then we will run a start operation on the script. So mtask engine start measurement, or start script, or run start script. Start script sounds good, and we always will make a stop script no matter what. Okay. Let's take a look to our script engine. So in our script engine currently run test, and everything runs in the same thread. So if we would have the script locking for some longer time, that would not be great. So we need to improve on this as well. First let's add the missing functions. Start script, stop script, run test, start script, stop script, so that we have this. Also we should log errors, like with the to 0. Yeah, so status equals this, and if that, then error starting measurement script. Starting measurement, error starting plugins, error starting script. Stopping script. Right, but before we populate those functions, we should generally make the whole thing run in an own thread. So let's change this to a Q thread. Which complicates things again, because then the engine itself should be created in that thread, and then the engine itself should not have a parent which belongs to another thread, so we need some sort of a proxy object. Script which paradoxically will be called a script thread, but it will be more the object inside the thread and not the thread itself. That's why it will be that is why it will be derived from just QObject. And technically we will never set a parent, but for completeness let's keep this here. Okay. Yeah, so if this is a queue thread, then it is a protected function. One, override. The p engine will be moved then to this thing. Let's not call it thread. Let's call it engine runner. Because thread somewhat suggests too much that it is a thread object. Did we use this somewhere? We did not use this, so we can just get rid of this. We will need a script copy. Qstring script set script. Okay, so this will now be a bit more changes. Run script. We could have run also maybe more here-ish. Oops. So there will be our script run. This thing will become part of the script run. This will be just script is equals script. This will be not engine but engine runner. Engine runner, can still keep it called engine. Signal log line. This wants to emit so let's put this signal on the runner. Then this function here will also be on the runner. So this function become part of the runner, which we should define somewhere separately. Actually, we could just put this in the header file and keep probably the whole runner implementation just in the header. That would be probably convenient. Okay, so object qthread q. Then this just always waits, so we should never kill this while the thread is still executing. Okay. Run we will have to do. Run test we also have to. Okay, so right here. So run starts in the new thread. So here we are in the new thread. We however need to communicate the script to it. So here let's add the parameter qstring reference const script engine script script is equals script. We will also need a way to retrieve it. Just qstring get script const oops, mscript. That should not be complaining. Yeah, now it's happy. Okay, so, and to run, we will generally need a run function that starts a specified function. So let's create a protected functions, first functions, then variables. Protected function, yeah, int run script const time reference and entry point. Run script entry point, and here we just return entry point on test. This we will copy for later. And start will be just the same thing, just that it will run script on start or main. Let's go main. So here we'll change the entry point from on test to just test. Okay. So our run script. First we'll need to check whether that thread is running. So if is started. Let's see what we have available on our thread to check its state. Zack. Is running sounds good. So if is running, then return login error already running, else start. Yeah, and if we start, then we start here in this run thingy. So plugin not plugin, script runner, just call it runner without any additional parameters. Script script don't we have a wait, that's not script engine, that's script runner gets the script. Didn't we have script? Yeah, qstring script, and runner should have qstring, and it should this thing needs to be ptr. And this is quite not safe. We need a mutex to guard this script mutex. Q what did we just use? Normal? We used a normal, okay. Q mutex local script mutex reference lock punct unlock, and then of course we need a lock when we set it. What do we have here? Set script. Okay, so we create our runner. The runner will internally create an engine. Okay, so we are definitely well, we could let's keep it. Friend class script engine, so let's go with this approach. What was it there? Right here. So runner dot engine runner as a parent, reference of course. Engine handle, engine, okay, so we have of course evaluate. In this case we don't even need to set the script here, we can just keep it there. That will be elegant enough. Just okay, let's do it like this. Q string script. We just make a copy of the script here, and then we unlock the mutex and we can evaluate here. We will need some means to communicate back if this thing failed to pass the script, but this will be something for later. To do pass error back to script. Just log the error, script compile error, and return without. I mean, we need at least a cheap way. Let's do it like in a. No, we'll do it correctly later, because if we try to do it cheaply now, it will not be elegant. Right, and so runner engine. Alright, and here is already on test. We set entry point, which we now here have not communicated. Need to communicate this as well. So we have here our set script, and we have here our run. This is not quite elegant. Ideally we should create also a thread object. Unlock, but for now this will be good enough. Point. I already have a semicolon. Right here, so we want entry point. We log the error. We return from here. In this case as well. Then we get the function. Then we return again. And we don't have a return okay or anything. Good. And if as soon as we return out of the run function, the runner here will be deleted, and thus an engine which is which has it as parent will be deleted. We need to here add although a few more small things, because we have here this log function which now is called on our runner. So we want to connect reference runner signal what was its name? Signal logline with this comma signal. So we can connect a signal to another signal, and then if you trigger the signal on this object, it will automatically trigger the signal on the other object and then pass the signal further to the rest of our infrastructure. So let's see if at least our test function still works, if we haven't broken anything. I guess we used red ones too often. Yeah, so like this. Right. Just always here return true. Or since we are not validating anything, let's just make this a void function. Set script. Oh, I think I made it static accidentally. This should not be static. Okay, load test, it's fine. Don't need that breakpoint anymore. This will be renamed to just test. Then we will save it. I will override test, it's fine. And now let's run test. That is not quite okay. Right, because we had an object called test. That's annoying. Let's call it test main. So our test code will then be called test main. Okay, run. Yeah, and it works. Although it should not say unknown plugin. We broke something. It should fill in the name of the plugin automatically. Okay, so we end up here. Also logline didn't work. This should have also let's test this if this caused a yeah, so this logline is broken. Not great. Output oh, I have screwed up the signal connect. Was that here? It's missing the argument list. Or we can go with the modern approach of using the syntax, and Rana is of type Rana. Though I didn't actually try whether this syntax, oops, that's the wrong approach, works like expected. Let's see. So we have 2 bugs to fix. This we forgot. Load to run test. Well, okay, so some connection is still not connected. Or the other thing breaks, so let's comment this out. Nope, our logging mechanism is broken. Maybe it's broken here. Run, okay, so this this thing fails. Okay. Let's see, object. Did we set the wrong object? Native context. Yeah, this should be. Actually, we could even go without the redirection. But let's keep it on the safe side. This should have been reference runner. Right. Load. Then run. Okay. Yeah. Okay, so this works, but this call here does not. also we don't get the other message, so there is something else not quite right. We had a breakpoint, but we removed it. Where was it? Let's look for it again. Unknown. So let's here my log run. So we log the plugin index. We look for the instance, or it's some instance. But it's apparently not the right one. And then of course we get plugin unknown. But it bugs out after the first function. It then something does not work as it should. My log line. Plugins call function. Okay, breakpoint. Red is red is invalid. It shouldn't be -1. So we have function. Oh, we always return not implemented. That is actually intended to fail the way it is. Let's just change it to some success message. Then it shouldn't abort. Plugin OK. Load. Run. Yeah, and now it doesn't abort anymore, but we still have the problem that somehow we are not able to properly resolve the instance for our log message mechanism. Let's put a breakpoint here. Load. So let's see. We pass this out, so let's check the values instance. Okay. Passing this. Well, that seems correct. Then we are here on the instance of the plugin itself. What was this here? That looks also correct. Well, so plugin instance seems right. And here we are going through all the plugins through the list. So instance is still the same value we expect, and plugin data has a different internal value. Pointer. Oh, this thing, this is of course completely wrong. Get. We need to add a get instance function or something. plugin. This thing does not have an own instance. We only have the instance on the DLL plugin. Um, hmm, 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 hmm. And we could just make get instance on the other one. Um, um, Punkt, what was it? Do we have a? We don't have a option to get the value out of it. We can use the arrow operator, the asterisk operator. Let's just add a get function. T asterisk get or data or raw. Yeah, that's a good name. Okay, so plugin instance punkt ptr, and on our plugin we will just define this thing as a virtual function which is to be always provided. Just that this thing in other implementations will just return itself. And it's a const. One space too much. It doesn't matter. Okay, now it should work. Oh, maybe not. What did we break here? Per instance, the function ptr must be a const function. Zack. Load test2 run test and test message. Yeah, that works. Okay, so the application is becoming more and more complete. Are there any questions at this point? Okay. If there are no questions, then we should quickly finish one thing which we forgot, namely here the remove everything, clear. But let's make a separate function for this on clear. And we'll make it a slot since we might want to have a button that clears everything as well. So actually on clear we'll also clear the text. And then we need to get rid of all the plugins. So we could just get plugin manager reset or remove all. That's a nice name. Remove all. And that should be it, since our mechanism then should dynamically update the tree. So we just need to make this remove all on our plugin manager. Add plugin, remove all. Oh, we don't have a remove function either. That might be something we will want to improve upon. So we lock the thing. We have here our, but this is a write locker now. and for every plugin, I mean, we could just copy it, could not log, get plugin list, then this will give us a copy. And then for every plugin we just call remove plugin. And then here, then we need a write log. Write log, plugin list, remove. This is just a list, this is annoying. Then let's just leave this as a to-do. Let's leave this as a to-do because we need to traverse the list and find that this is something that is not so elegant. Plugin list, because here if we don't do that we can just clear the list further down, and here the plugin itself, auto plugin is equals plugin list punct or at e. You can take this as a reference. This is not correct. Then we want a different loop. For if e is equals 0, e is less than plugin size, e plus plus. We can take this as reference, and once we're done with it, we can clear the pointer, and then we just clear the list. And plugin. Actually, do we need to do anything more? We can just so the plugin will be deleted automatically when we clear the plugin pointer. DLL plugin. Yeah, and this thing has here the smart pointer, so this actually should be quite. Actually, it should be as trivial as just really only a clearing. Thanks to our use of a lot of smart pointers, that should really be as simple as it gets. If we wouldn't have this many smart pointers, we would need to manually clean up things, but that seems that it will not be necessary. Let's add a clear button so that we can test this explicitly. Where was it here? Separator. Clear on clear. Right. Let's see. And but we will want to have a breakpoint in our demo plugin destructor to see that everything happens as it should. So we load something. Now we have test, and now we press clear, and we reach the destructor, and we do this from our somewhere deep from our let's see, data panel, remove all. So really just by clearing this thingy, we trigger the one destructor, which triggers the other destructor, and the thing does what we want. Although this didn't get updated, I think we might need to set the plugins dirty. We forgot to do this. We are setting it here, but not there. Okay. Load, add, clear. Don't need the breakpoint anymore. Yeah. On do we have a here a remove on move plugin? Right, and this was a homework, so there should be an existing implementation of the remove single plugin function in your homework already. So we will leave this still as a to do, and we should think about some homework based on this, on the current state of the project. So let's assume what we would like to have that would not be too complicated, and at the same time be something that we will not urgently need in one of the upcoming lectures. Tests. Okay, I have an idea. So when we have something, or some plugin loaded and we start the thing, it will start, as you see here, of course, plotting the data until we stop it. And now, since we stopped it, let's see if the stop is destructive. On stop, plugin manager stop, script stop. Right, and if we start it again, it just continues where it left off. Okay, so we would want two things in this mechanism. So first of all, start should reset the states. On timer, plugin list, upload. Right, start here this thingy. On start we will put here so that it actually resets all the states. We have the ID, we have the stream, data channels, and here we always get samples. So this we will want to reset. Yeah, so this is clear, and can we set this to 0? I think we can null this just like this, comma 0. Can't we? Const float should be fine, but this will not do much. It's ambiguous. Yeah, it doesn't know what it is, so let's say double 0. Then it won't be ambiguous anymore. But since we are getting the things from our plugins and they have it cached as well, we should reset it there too. Okay, time samples. On data samples, let's see. Right, and here we can differentiate between those two operations. So let's go to our start, and here we will clear those two entries completely, so that but it's just for the DLL plugin, but this is okay. So now when we start, we need to load, of course, something. Then we can start. When we stop it, and when we start it, it starts over from 0. But when it's stopped, this data still exists. It's kept on the plugins, as well as it's kept inside here the structures which represent our individual plot lines. So in principle, this clear could also be moved to stop without any problems. So let's do that. Load, start, stop, start, stop. Yeah, and the assignment will be, I think it's not too difficult, since the data all exist here, will be to add like a well, dump data functionality. So we will add a start, stop, dump, start, stop, save data, start, stop, clear, config. We should say what is what so that it's clear. Start, stop measurement, save data on let's call it on save, sounds nicer than on dump. Okay, good. On save. Right, so what's today? 11, 12, 2025. And before this, let's just quickly make a short demo. Get save. There was some option to get a save directory name. Was it Q? We have this Q file dialog. File mode directory. So this is somehow doable. We just have to see how to do that. File mode. Yeah, this is get existing directory. That's what we want. Directory. This comma caption. Save data, save measurement data to directory, to files, okay, and of course if this is null then nothing. So homework, save all scrolf s data and y data to files. The file name should select as a plot name, from backend. The file name must be set to be compatible with allow the path characters, no \\pipe etc. Replace invalid with underscore. Yeah. Each file should contain one channel. Format should be select selectable. But how do we select the file format when we select the directory? Then we need to show a some sort of combo box dialog. Let's keep it simple. Channel in comma separated value at the attention to the file names. And it should be always like x1 epsilon1 x2 epsilon2 and so on, like this. So we just really have just pairs from both arrays written down to a file, and as much of the file as there is. So we just save everything. Each channel gets its own file, and yeah, that seems simple enough. Yeah, any questions? Oops. Okay. Cute. So if there are no more questions, then we should proceed with testing our script a bit more. So the script needs an entry point, which we're actually missing, and we also can notice that we, I think, are not getting any errors, which suggests that we have some bug somewhere, because when we load configuration and then start measurement, no, it's complaining, so it's fine. It says that mine not found. And measurement stopped. So now of course we need to add a main function to our script. And we will want the script to be able to stop the measurement somehow. So we'll also like a wait function, so let's use it. It doesn't exist, so it would bug out, but we'll add it soon. Let's say 3 seconds of measure, or 10 seconds, 5 seconds, 5 is a time that is not too long to wait. And then we want to stop the measurement, so it should work. And then we will add such these two functions the same way as we added log line. Now we just, however, say store the config, and let's add those two functions. Script engine. So we have here our fx log line. So signal stop. Request stop, or just stop. The thing is, there is a stop on the engine itself, but lowercase, so I kind of want some nice name. Let's call it end. This is a good enough signal. We could actually rename it from stop to end later, and we'll just stick with this nomenclature. Then here, of course, we'll have a which we don't really even need to go make it like this. We can move this somewhere else. It will oops. Mm, that's why we did it. We wanted the translation, the TR thingy here. Although we can put it there as well. Right here. So this is here. This is here, and TR was on Q, and not sask. We just need to specify some object on which this translation should be. Okay, so add here. Right, we'll connect end request and or should we call it finished? Doesn't matter. So we have wait fx wait and end fx end. Fx wait and fx end. Let's see, can we improve this somehow? In principle we can make a shared function. We kind of we should not improve it too much. We have enough differences in the whole thing. Let's keep it maybe a bit more redundant, but more readable. Okay, so right, and actually we don't need this. We don't need any of this here. The wait function can be actually much simpler. So this this would actually be what we want to do in our end function. Per engine init end. Okay, and here in this function we really only need to read the argument 0, where we need to check whether it's actually present, of course, first. Sac. And if it is, then we just did Q in 64 ms milliseconds and Q3 sleep ms milliseconds, although this is a bit dangerous because if we specify a very long time then we have no way to bug out of that, but for now let's just keep it simple. Right, so we have this, we have this, we have somewhere this log line in our data panel. Script engine on end. I mean, or we could directly trigger stop end. Yeah, why not? On stop. And then we go to our stop, and this should work. The stop script kind of doesn't do anything right now. Let's put a breakpoint there and see that we reach it. That should work out quite nicely. So we'll load config again. We said we'll call this not stop but end. Save config so that we have the right value for later, and start measurement. So it's measuring, and once 5 seconds. Did it fail? Oh wait, main not found, it failed. That's of course a bug, it should be just main. Save config. plot start measurement. Error may not found. Okay, something's broken. Let's stop again. Let's see. Set script should be triggered. We don't trigger set script when we start. That's the problem. Data panel on start. Before we start plugin manager, we need to set. Before we start script manager, we need to set script. Set script. Okay, so we set script, and that will be correct. I have seen another issue. Let me just stop. Plugin stop. Yeah, it seemed that clearing this on, so that should work. Yeah, washed. Be fine. There might be some small timing issue which we can resolve later. Load. Start. Let's check main. Okay. Start measurement. Now we set. We stopped instantly. Then our wait didn't wait. Then our wait failed. Script engine. The wait didn't wait. Arg0, of course. We waited 0 seconds. That explains the behavior. Load config. Start measurement. And stop measurement. Haha. We have somewhere a bug in the plugin that it like takes the time it already cached once, and then we always get this jump. We should fix this, but I think this is a plugin bug. Plugin to get samples. Somewhere is static, something static. Worker started. Well, we should start the worker each time. So load start measurement. We start the worker, and then we are done. Then we start again. We start the worker again. So the times should be correct. We might have some stuff kept here in this thingy. Let's see if we forgot to clear this. Probably. Although reset, resize. Yeah, we resize it to the channel count. We should first clear it. Because if we resize the same value, it's a no operation basically. Load config. Start measurement. Okay. Start measurement. No, it's still not fixed. That's something we will fix next time. Since we are running out of time already, I think this is a good place to stop. The lecture next during the next lecture, I will assign you the final project that you will have time until end of January to complete. I can tell you already now what it will be, but mainly since we added here the option to save the data to a file, what would be nice would be the ability to view the data somehow. So the assignment will be to create an application of your own, which is a sort of data viewer, and can load arbitrary files, so not just CVS formats, but a few more formats, and display them in such a QWT plot with additional functionality like the ability to move the offsets around in time and in space to scale the loaded data, etc., etc. So I will formulate that in details during the next lecture. And during the next lecture, we'll also still keep improving our data panel application. So we will make a proper stop mechanism so that we can interrupt the script execution even if it's doing something still. If we press the stop button, we will ensure that our sleep cannot block everything forever if we forget to release it, and stuff like that. Yeah. So are there any questions at this point? Okay, no questions. Then let's stop the recording.